This video is going to cover section 3.3, the conditional and the biconditional. So we have a definition here right off the bat. It says a conditional statement can be written as either if P then Q or if P comma Q. So just so we know what we're talking about here, this is the one where you have P and then the arrow Q. Okay, if this, then that. Okay, P is called the antecedent. Not sure how to say that, but antecedent, and Q is called the consequent. Okay, so we're going to go ahead and just in this first one, just identify what each one is. So let's say if we have letter A, if I study for at least 6 hours, then I will get an A on the test. So I would say that this part right here, I study for at least 6 hours. This would be P, the antecedent. We'll say it like that, antecedent. Okay, and Q would be the part right after. So it'd be the Q is the consequent. So I will get an A on the test. Okay, using the same color scheme, we're going to go ahead and do the other part. So letter B, if I get the job, that would be your P. Then I will buy a new car, that would be your Q. And notice that this one uses the second one. This one uses the P comma Q. So P comma Q. But it's the same thing. Okay, the first one was using this one. Well, I shouldn't put it that way. They were saying P then Q because of that then. But they mean the same thing, okay? And finally, if you can dream it, you can do it. So if you can dream it, so you can dream it would be your P, and you can do it would be your Q, the antecedent and the consequence, okay? We're gonna go right into an example, I believe. Oh, not quite yet. So here's that arrow notation I just showed you right now. The conditional statement if P then Q can be written using this notation. So P then Q. Okay, and it's right here as well. It's read as if this, then that. So if P then Q, or you can also say P implies Q, which is a little bit more college term. Okay, so we're gonna go right into our truth table for this now. Remember that we discussed truth tables in the section before. Okay, so the truth value of the conditional if P then Q is going to be false if P is true and Q is false. So in other words, in this case right here, this is the only place it's going to be false. Okay, everywhere else it's true, and it is true in all other cases. And here is a chart for us to fill out. So we notice that we have the same combinations: true, 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 false, false, true, false, false, just like the previous video. So this tells us that Q. If P is true and Q is false, this is going to be false. So that only happens, let's see, the first one is true, true. So this would be true. Okay, let's use that other color because it's kind of hard to see. So this would be true. Let's see, P is true and Q is false. So that's exactly what it says right here, and this is the only case where it is false. Everywhere else, according to my definition here, it's true. So all you really have to remember is this one. If this happens, true, false, with P being true, in other words, the antecedent being true, then everything else is going to be true, and this one would be false. Okay? So let's go ahead and, I believe now we have a few examples here. Trying to show this up here. We're going to determine if these are true or false. Okay, so we're going to start off by underlining what's what. So remember, this one is your P. If 4 is greater than or equal to 3, so P, then 2 plus 5 is equal to 6. This would be your Q. So we're saying that P implies if P then Q. Okay, well, in this case, 4 is greater than or equal to 3, so that would be true. So the first one is true. So P is true. And then it says 2 plus 5 equals 6. Well, 2 plus 5 is 7. So this one is not true. This one is false. So according to our chart up here, okay, when we have a true and a false, that would be this one, true and a false. This would be false. So this one is a false statement. See how it kind of works? Moving on to the next one. If 5 is greater than 9, remember this is P, then 4 is greater than 9. Well, let's look at the first one. So we have if 5 is greater than 9, that's false. I would say this is false. But at this point, it doesn't even matter what this is because if you notice, both of the false are going to come out true regardless. Okay, so this one is true. And the last one, if Tuesday follows Monday, so this is our P, then April follows March. All right, let's see. Does Tuesday come after Monday? Yes, that's true. So far we have it can be either one of these two. Okay. So we got to check the second one. April follows March. Does April come after March? Yes, that is also true. So we have this case right here, which means that it's true. This claim is true. Okay. And that's how these work. All right. So I'm going to go ahead and jump into now a more complicated example. We're going to make a truth table for the following. Okay. So remember that with the truth table, we always start with P and Q. And then we go all the way across because we don't know how long it's going to be. And we're going to go ahead and do our 4 here. Okay. And we're going to fill in all the possible values for P and Q first. So we can have that they're both true. We can have that the first one is true, the second one is false. This one can be false and this one can be true. And then they can both be false. Okay. So that takes care of our original P and Q. Now we're going to see what else we have in here so we can go ahead and put it here. So I already have P, but I don't have this one. I don't have P implies Q. Okay, so I erased that. So I'm going to go ahead and do that first. So let's go ahead and do P implies Q. For this part, you have to kind of, if you don't remember how to do this, you need to refer back to the chart that was up here. Okay, this one right here. This one gives you all the possible values for P implies Q with P and Q. And basically, if you remember, this one is true in all cases except where P is true and Q is false. So that happens right here. P is true, Q is false. Everywhere else, it's true. Okay. So now we're going to go ahead and do this entire thing. So now we're going to do, I should do that. We're going to do all this now. Okay, so that would be P implies Q and P. Okay, don't let those brackets freak you out. It's just like another set of parentheses, okay? It means we have to do the inside of this first before we move on. So now we're going to do all of this part inside. Well, for this part, remember that and, which is this little symbol here, means they both have to be true. So I'm looking at, just so we know what we're looking at, I'm looking at this column and I'm looking at the P column because that's the second one, P right here. Okay, P. So I need these both to be true. So let's see, those are both true. So yes. These are not. We have a false, so that would be false. That one's false, so this is false. And that one is also false. So the only one that's true in this one is the first one. Okay. I'm going to go ahead and do the last thing now. So I'm going to go ahead and do the entire thing now. So I'm going to do P implies Q and P. And all that's in another set of parentheses or brackets if you prefer, implies P. All right. So for this one, you have to be a little bit careful because first of all, we need to see what we're looking at. So it looks like we're looking at this column, so this one in red, and we're looking at P. Okay, but for this one, the order does matter because the first one is your antecedent and the second is the consequence. So we have to look at the first one first and say, if this is true and this is false, that's the only time it's going to be false. So let's start with that first. So let's see here. So this would be first, and this is second. So we're going from here to here. Okay, so if this is true and this is true, well, then this is true. Because again, remember that up here, you have this right here. If they're both true, then it's true. That's what I'm doing down here, okay? Next one. If this is false, then this is true. That's also going to be a true statement, okay? If this is false and this is false, that's also a true statement, okay? And if this is false and this is false, that is also a true statement. So it turns out in this problem, they all came out to true. And the reason that happened is because we didn't have a true going to a false, okay? So because we didn't have that, this one came out all true, and in case you forgot, this is also called a tautology. So a tautology is when all of the truth values in the end come out to true, okay? That's it. That's how you would construct a truth table with something like this. So let's go ahead and I believe that's it on this side. We're almost done with this video. It's kind of a short one. Look at the last problem. There's a couple problems left, I believe. So we have an equivalent form of this if P then Q, okay? And that's going to look like this one right here. So in other words, this is equivalent to this. We're not going to prove it. You could do the table and prove it, but we're not going to do that right now. But pretty much, if P then Q is equivalent to not P or Q. Okay, so what I'm going to do to kind of show you how this works is to rewrite these two, A and B, in this other form. And by the way, this form right here is called the disjunctive form. It's called a disjunctive form because we have the disjunction symbol right here in the middle, which is that or. Okay, so I'm just going to go ahead and rewrite this. And actually, I think I'm going to type this just to make it fat. Well, let me label it first, and we'll just type it out real quick. So this would be, let's see, if I don't move to Georgia, okay, so this is your P. I will live in Houston. This would be your Q. So in this one, we have this implies this. We're going to change it to this second format, okay? So let's go ahead and do that. Let's use this one. And let's make it a little bit bigger. That way you all can see it. Oh, all right, there we go. So for letter A, if we were to go ahead and change this to the disjunctive form, if I don't move to Georgia, you would have to change that P to a not P. So it would be if I do not move to Georgia, okay, like so. If I do not move to Georgia, or because that's the middle part right here, I don't have to put a comma in this case. If I don't move to Georgia, or Q would be the same. I will live in Houston. Yeah, that's pretty much it for that one. Okay, so let's just double check. So we have that not P or Q. So then not P would be the opposite of I don't move to Georgia. So I do not move to oh, I think we messed up there. Yeah, we did. Sorry about that, guys. It would be if I do move to Georgia. So let me do this. There we go. Simple fix. Okay. So again, what I did here is I went ahead and changed this not if I don't move would be if I do move. Okay. So not P would be if you do move to Georgia. And then or, so there's my or, I will live in Houston. So I will live in Houston stays the same. Okay. Let's try the second one now. We're going to try this one. I hope I don't mess up like the first one. Otherwise, I'll owe you some homework points. So for letter B, so you all can see it. Okay. For letter B, we're going to go ahead and change that to the disjunctive form as well. It says if the number is divisible by 2, then the number is even. So if we change it to the other form, it would be if the number is not divisible by 2, or, okay, the number is even. Okay, and that's about it. So in this one, you see, just like the one before, we're changing our P, okay? So the P is now, if the number is divisible by, I'm sorry, it's not divisible by 2 because this one was is, and then the other one stays the same. The number is even. Yeah, it should be number. Number is even. Okay, and that's pretty much it for this part, guys. You're just rewriting this form into the disjunctive form. Okay, I think.